You probably remember learning about the water cycle back in school, right? Evaporation, condensation, precipitation. Well, what if I told you that entire system is now being pushed into overdrive? Today, we're diving into how our warming planet is supercharging one of the most fundamental systems on Earth. So let's just ask the question straight up. What actually happens when you turn up the Earth's thermostat and supercharge this cycle? Well, as you're about to see, the effects are way more profound and interconnected than you might think. All right, first things first, let's get into the core idea here. The planet's hydrological system, which is just the fancy term for how all water moves around the planet, isn't just changing a little bit, it's actually accelerating. It's going into high gear. And this is the part that's so crucial to understand. This isn't a small tweak. We are talking about an intensification of the entire cycle. When you add more energy, more heat into the climate system, you get more evaporation, the air holds more moisture, and that leads to more precipitation. The whole machine is just running faster and harder than ever before.
Okay, so how does this work, really? What's the mechanism behind it? Well, it actually comes down to some surprisingly simple physics. It really just boils down to two key principles. First, as the planet gets hotter, water just evaporates faster. That makes sense, right? And second, warmer air can literally hold more of that moisture. You can think of it like a giant atmospheric sponge that's getting bigger and bigger. And you can see how this creates a clear chain reaction. The temperatures go up, which provides the energy for way more evaporation. Then the warmer atmosphere soaks up all that extra water vapor. And the result? A supercharged cycle. There's just more water moving through the entire system, and it's moving a whole lot faster. Now, if you really want to see this process in action, you have to look north. There is one place on this entire planet where these changes are happening faster and more dramatically than anywhere else. You know, there's a reason scientists call the Arctic a barometer. Just like a real barometer measures changes in atmospheric pressure, the Arctic measures the pressure we're putting on our climate. The changes that we're seeing up there right now are basically a preview of what's coming for the rest of the world. And get this, here's a number that is just staggering. The Arctic is warming at more than twice the global average rate. I mean, just let that sink in for a second. More than double. And it's that incredible speed that makes this region so absolutely critical for us to understand. So what does all this rapid warming actually do on the ground? Well, as the sea ice melts, that dark ocean water underneath gets exposed, which leads to, you guessed it, more evaporation. All that extra moisture in the air has to go somewhere, so you get more precipitation. And here's a huge one. More of that is now falling as rain instead of snow, which totally rewrites the rules for the ecosystem. But this isn't just a simple one-way street of cause and effect. Oh no. The changes that are happening up in the Arctic are actually flipping switches in the climate system that make the whole process go even faster. We're talking about something called a positive feedback loop. Now that sounds good, but in this case, it's not. It's when the effect of a change becomes a cause of even more of that same change. So the effects of warming are actually creating the conditions for even more warming. Now, to understand one of the biggest feedback loops, we gotta know one key term, albedo. It's actually pretty simple. It's just a measure of how much of the sun's energy a surface reflects back out into space. Think about it like this. Bright white ice has a really high albedo. It's like a giant mirror, bouncing the sun's heat right back out into space, which keeps the planet cool. But dark, open ocean water, that has a low albedo. It's like black asphalt on a hot day. It just soaks up the heat. So as the ice melts, we are literally flipping a planetary switch from reflective to absorbent. And the other huge feedback loop is the thawing permafrost. See, this frozen ground holds massive amounts of water, sure, but it also has gigantic quantities of organic carbon locked away inside it. As it thaws, that carbon gets released into the atmosphere as greenhouse gases, which, surprise, traps more heat and causes even more permafrost to thaw. It's another one of these cycles that just keeps feeding itself. So, we've been zeroed in on the Arctic, our climate barometer. But what do those readings really mean for the rest of us? Let's zoom out and take a look at the global ripple effect. And if there's one thing to take away from all this, it's this. What happens in the Arctic does not stay in the Arctic. The changes up there have these massive, profound consequences for weather patterns, for water cycles, and for sea levels all across the globe. And those impacts are incredibly widespread. We're seeing precipitation get way more extreme. You know that old saying, the wet get wetter and the dry get drier? That's what's happening. It leads to devastating floods in some places and crippling droughts in others. Rivers are getting all out of whack because snow is melting earlier, which messes with our water supplies. Of course, all that melting ice from glaciers is pouring into the ocean, raising sea levels. And it even changes the amount of moisture in the soil, which has huge consequences for the food we all eat. Because at the end of the day, this isn't just some abstract science experiment. A supercharged water cycle is a direct threat to the stability of our ecosystems, the reliability of our global food supply, and maybe most importantly, the availability of the fresh water that every single one of us needs to survive. And that really brings us to our final thought. That Arctic barometer, it's giving us a crystal clear reading. It's showing us a future with more extreme weather and massive changes to our world's most vital resource. So the only real question left is, are we listening?